Okay, interval of convergence for the function and the derivative. These ones are long. So let's see, what do we want to do? We need to use start with the ratio test, right? If we want to find the interval of convergence, the best tool is the ratio test, which we learned before, which goes something like this. I want to take the limit of the ratio of the next term divided by the ratio of the n plus first term over the nth term, right? Absolute value of that. So that means I'm going to look at the next term, that's -1 to the n plus 2, next term, times x minus 4 to the n plus 1 divided by n plus 1. And I'm going to divide by this term, which is the same, of course, as multiplying by its reciprocal. Okay, and then we're going to take the limit as n goes to infinity, but first we can clean that up a good bit, and this usually is the case. So what I'm going to do is I like to just isolate my n's. So I got an n over n plus 1. And then what's going on with all the x terms? Well, x minus 4 to the n plus 1 divided by x minus 4 to the n just leaves you with an x minus 4. And then so I've taken care of that, and that. So now I got a -1 to the n plus 2 over -1 to the n plus 1. So remember, you're subtracting. So that's just going to leave you with a -1. And we could put him wherever I put him here. Okay, so it cleans up pretty nicely. So I'm looking at the limit as n goes to infinity of all of that. So the absolute value of -1, we're not going to have to worry about that. So n's are also positive, so we can get rid of him. We're going to look at the limit as n goes to infinity of n over n plus 1, and then times the absolute value of x minus 4, which isn't affected by our limit. Okay. And this, of course, is that's infinity over infinity, so you could use L'Hopital's rule, or you can go right to the fact that that's going to be 1, right? Because we know that the powers are the same, and we have a rule for that. That was a horizontal asymptote back in algebra class, 1 over 1, okay? So that means the limit as n goes to infinity is this, and we know that this converges by the ratio test whenever this is less than 1, okay? So that'll give us our radius there. So remember how to solve absolute value inequalities. We put that between 1 and -1. We add 3 to both sides, and that gives us our radius from 3 to 5, right? So what we're saying is this series will converge when x is between 3 or 5, but we're not sure about the 3 or 5, right? We got to check the endpoints. That's our last thing to do, and usually should be pretty straightforward. I'm going to put in a 3 right here and a 5 right here and see what happens. So let's see, that's going to be n equals 1 to infinity, -1 to the n plus 1 times, plug in the 3 first, so we'll let x equal 3. Plug in the 3, that's -1 to the n, and all divided by n. Okay, so going back a few sections, what's happening with that guy? Well, let's go ahead and let me just write down 5 while I'm here, and then we'll take a look at them. So that's going to be -1 to the n plus 1. And if I plug in the 5, of course, I'm going to get 1 to the n, all divided by n. Okay, so what's going on with these functions? Well, you can add these together, right? If I want to look at this, simplify it first. -1 to the n plus 1 times -1 to the n is -1 to the 2n plus 1, right? N plus n is 2n. So we get, as they go from 1 to infinity, -1 to the 2n plus 1. And that's important because that's going to do something a lot different than -1 to the n or n plus 1. Okay, so this is going to diverge. What do we have here? This is always negative. It's not alternating series, right? Think about it. 2n plus 1 are odd numbers as you plug in the counting numbers 1, 2, 3, and 5. Every time you plug in a positive integer here, you're going to get a -1, right? So you just keep adding -1 over n, or if you want, it's just going to be a negative 1 over n, right? Because that's always negative 1, always be negative 1. So this is probably a better approach. And then we recognize that series, right? That's a p series with p equals 1, so that diverges. Okay, let's take a look at the 5. Well, don't have to worry about that. That's just 1 to the n. So now I have this series. What kind of series do we have here? Negative 1 to the n plus 1 over n equals 1 to infinity. That is an alternating series, right? Alternating series that's always decreasing. So that's going to converge. Sorry, it's alternating series where the a to the n term, negative 1 to the n plus 1, 1 over n, that's a to the n, right? And that guy is always decreasing as n increases. So this is going to converge by alternating series. Okay, so my interval of convergence for the function now, oh, here's the answer. No, that's not right. Should be from 3 to 5. And then we do that, right? Because it'll diverge at 3 and converge at 5. This is the copy and paste solution from the book. That doesn't look right to me. I guess they just missed that bracket because they have diverges like we do and then converges here. Okay, so let's do the derivative now. All right, so here's my solution without the work. There's your derivative. Let's see if that makes sense how they got that. So let's just do it up here. F prime is, bring the n down so the n's go away. So it's negative 1 to the n plus 1. And then you have an x minus 4 to the n minus 1, right? Bring the n down, cancel out, take 1 away. All right, so there's your derivative. So let's take a look if we agree. That looks right. According to the book, that's the solution. Let's see if we can get that. All right, let's do it again. We can always use practice with the ratio test for convergence. So let's do it. So the limit, I want to know when this thing converges. Let's see if they're right. N goes to infinity, ratio test. The next term, negative 1 to the n plus 2, x minus 4 to the n. And then I'm going to divide by this term, right? So we can just go ahead and divide since it's not a fraction. And that's negative 1. Oh, it should be the next term. I missed it. n plus 2. Negative 1 to the n plus 1. And then that's going to be x minus 4 to the n minus 1. Take the limit of that as n goes to infinity. And what do you get? So remember we can subtract these. What's n plus 2 minus n? N plus 2 minus n plus 1. That should just be 2 minus 1, which is 1. So we get negative 1 without a power. And then we have same idea here, x minus 4 to the n divided by x minus 4 to the n minus 1 just leaves us with an x minus 4. Okay. And then the absolute value negative 1 is 1, so we don't have to worry about that guy. And then we end up with the same expression as long as that is by the ratio test, as long as that's less than 1. Then we have convergence. So we still end up with this, right, which is pretty common for the derivatives. And we just have to check the endpoints again, right? So we know the interval of convergence is from 3 to 5. However, what happens at 3 and 5? Well, let's see. Negative 1 to the n plus 1, x equals 3. When x equals 5, negative 1 to the n plus 1. And then when you plug in your 3, you get a negative 1 to the n minus 1. And then when you plug in your 5, you get, of course, 1 to the n minus 1. And then what kind of series are we looking at? right? So this would be, if I added these together, that's just going to be -1. Add these together, that's a to the 2n, right? Which clearly diverges. 1 plus 1 plus 1 plus 1 plus 1. And then how about this guy? This would be alternating. This alternates, but this guy isn't decreasing, right? So what we're going to have here is also divergence. So they're both going to diverge. And then we know that this is it, right? So this would be diverges. And if I want to reason, which I usually do, you should put something in here. That's an alternating series, right? That alternates, and this term isn't decreasing, it's staying constant. It's just 1. So that diverges by alternating series. And then this guy diverges. Pretty straightforward there. We're just adding 1 to itself an infinite number of times. Okay, so those are going to be some of your more challenging ones, I think. But study that process, right? You always go. There's some issues with this on these ones on the quiz, but definitely. So you want to take a look at that process. It's pretty similar every time you do it. If I ask for derivatives aren't that bad. It's this ratio test you got to be careful with, and then getting that result. Okay.